Okay, this example is the famous transportation problem. Suppose we have I factories on the left hand side, S1 to S3, and we have J demand points. Let's call them D1 to D4, for example. And the question is how much we can produce from each factory in order to minimize the objective cost, and also knowing that the capacity of each factory is limited, the capacity of each route is limited, and also the demand should be satisfied. Okay, this is a famous transportation problem. We have some factories on the left hand side, and we have, these are the factories, these are the demand points, and we know the demand of each point and the capacity of each factory and the cost of production and the cost of transportation. So the question is, in order to satisfy the demand on the right hand side, how much each factory should produce, and from which route we should transport these products from the factories to the demand in order to satisfy all the constraints. So there are two sections in objective function. So first of all is telling us the transportation cost. It depends on the distance between the nodes and also how much goods are being transported from I to J. Hi, this is the transportation problem. In this example, we want to know if we have some factories, let's call them I, and they're running from S1 to S3, and there are some demand points D1 to D4, and the question is how much each factory should produce in order to minimize the objective function, which is the summation of the production cost and the transportation cost. This is the transportation cost and this is the production cost. And also there is another thing that should be satisfied, that is that the capacity of the factories are limited and they should produce between some specific ranges, and also the demand at each point should be satisfied. Okay, so let me talk about the Pyomo code for solving this problem. So first of all, as usual, we have to import the required packages and then define the required sets. I and J are two different sets. It's an abstract model. We have a demand which is defined over J, P min, P max, and costs are the parameters. So and also the distance between different nodes are defined as a parameter. There's a variable x telling us how much good is moving from I from factory I to the demand point J, and it is defined as a real number. We could define it as a positive real. and also it has a bound between 0 and 300, for example. And there are some bounds for the generation side or the production side. You can say model.p is defined over I, is always within this bound. And also how much we are producing is calculated this way: summation of I and j, or summation of model x, model x ij for j in model j. Maybe we can improve it, but we will see. And also this constraint is on the production side, and also this side is ensuring that the demand is satisfied. I intentionally put it bigger than equal to the demand because it's easier for Pyomo to solve it, but it will not produce more than what is needed. Okay, so this term is the production cost, and this term is the transportation cost. So everything is fine here. And also the objective function is this, and we want to minimize that. The model, as you can see, it's a linear programming one, and also we have to specify the data. So as you saw, we have some parameters defined on I. So param over I, 1, 2, 3, p mean, p max, and cost. And if we have other characteristics, we could put it here. And also parameter j, it is defined over 1 to 4, and the demand is specified here, and the parameter distance. The distance between each pair of nodes are given here. Okay, so you have to specify that in your dat file. And if you solve it, let me run the tabs one by one. This one is run, this one is run, and also this one is run. You can see the objective function is calculated here, and if you want to visualize the decision variables, you can do it. So I run this tab. So these are the results. Let's read them. It is telling us that the amount of transportation between production 1 and demand 1 is 0. Production 1 and demand 2 is 0. Production 1 and demand 3 is 300, and so on. You could visually show that as well. So these are the results that are visually shown. And you can see the biggest transportation is between point 1 and demand 3, and the next one is between 2 and demand 1. So if we have a look at that here, it's here. So you see the next big quantity to be transported is from point 2 to demand number 1. Thank you very much.